time between source and destination we have two paths. Correct? So this time, as I told you in last class, that you need to perform this lab also, and my requirement is whenever any traffic from LAN 1 to LAN 2, any traffic which want to move from LAN 1 to LAN 2, it should use this path, means upper path. Router 1 should forward traffic to router 2, router 2 should forward it to router 4, like this. But whenever any traffic will go from LAN 2 to LAN 1, it should move using this path, means via router number 3. Router 4 should forward, whenever router 4 need to forward anything in LAN 1, it should forward traffic to router number 3. Router 3 should forward it to router number 1, and then router 1 will forward in to switch and switch to PC, right? Getting my point? So this is one pending lab of static routing that we are going to perform today. Today we will configure, like, let's say this PC will ping to this PC, right? First this PC will generate ICMP request message. When this PC will receive the request message, it will generate reply message, right? Reply message. So reply message should go via this path, and request message should go via this path, means upper path. And guys, instead of connecting switches here, I am going to create loopback. You all know what is loopback? You all know what is loopback? Guys, loopback is virtual interface on router. Virtual interface. Now question is why we have loopback. So loopback is for testing purpose. Let's say here in my home, this is my home router. This is my home router. Wireless connection are there, and my laptop is connected with this router wirelessly, and this router is connected with ISP, right? Let's say I am not able to access internet, or I am not able to access a particular service on internet. So I will complain to my ISP that I am not able to access particular service, or able to access the entire services on internet. I will complain to my ISP. What my ISP will do? My ISP will create one loopback here. My ISP don't know, let's say, IP address of this interface, or don't know what is the IP address on my LAN interface. This is my LAN interface, NIC. IP address on NIC is, let's say, 192.168.1.1. Fine. Here public IP address is, let's say, 1.1. Here public IP address is 1.2. Fine. So if ISP want to check the reachability, that problem is in inside network or in outside network, ISP need to identify. I have complained to ISP that I am not able to access internet. Now ISP have to check the problem is from my side or problem is from the customer side. Let's say here on this router NIC is not working. This NIC is not working. So this is not problem of ISP. This is my problem, right? Or let's say my laptop NIC is not working fine. This is my problem. So what ISP will do? How ISP will check that I am able to provide the services to customer, or there is some problem in my connectivity, like connectivity between customer router to my end, my services or servers. Where is the problem? So ISP can ping this public IP address to check reachability. Let's say ISP is in Bangalore, right? And ISP have this public IP address. ISP is going to ping this public IP address, and they have checked that yes, I am able to ping this public IP address. That means there is reachability till this router. Now problem can be here also between ISP router and my router. This is also concern of ISP. So ISP will create one loopback here. ISP will have one loopback. Let's say ISP have created one loopback here, 2.2.2.2. This is just for testing purpose, for self-testing. And ISP engineers are going to ping this loopback IP address, which is configured on my router. router, and if ISP engineer is able to ping this loopback, that means there is reachability between ISP to this router, means problem is from customer side, not from the provider side. So like here also, this is router, and here we have one LAN, here we have some user, these are, let's say, network engineer. This network engineer manage this network, right? There are some more routers as well, more servers are there, more switches are there, right? So if I want to access, let's say, R2, this router, right? Maybe here you can change the IP address between
Sir,
router 1 and
sorry to
router 2.
bother you.
Yeah.
Someone is waiting. Aurella. Someone is
Oh,
waiting to.
extremely sorry, let me check. Thank you. No one is here.
No, in the group chat he was. I guess he is using some wrong link. I guess in the group chat he is pinging.
Here, let's say we have some loopback 1, loopback 2, loopback 3, and loopback 4. On loopback 1, I am running network 10.1.1.0/24. On loopback 2, I am running network 10.1.2.0/24. On loopback 3, I am running network 10.1.3.0/24. On loopback 4, I am running network 10.1.4.0/24. You can see all networks are different, right? All are subnetted network. Now it means we have 4 LAN connected with router number 1. We have 4 LAN connected with router number 1, means one interface of this router is connected with one switch here, and then we have some devices, then we have another interface connected with switch, then we have one more interface connected with switch, then we have one more interface connected with switch. Okay, so instead of connecting switch here on router number 1 and on router number 4, I will create one loopback. Let's say on router number 1, I am going to create one loopback, that is 10.1.1.0, 10.1.1.0/24. Okay, that means one LAN is connected with router number 1, and here on router number 4 also we have one LAN, that is, let's say, 20.1.1.0/24, right? So this is LAN 1, this is LAN 2. Now between 10.1.1.0 and 20.1.1.0, there are two paths, right? There are two paths. One is via router number 2 and one is via router number 3. So what I want, that whenever user from this network send traffic to this network, traffic should go via router number 2, and whenever user from this network will send traffic in this network, traffic should go via router number 3. I will achieve this task with the help of static routing, and before running commands on this router, first I will write command in notepad. So let me open the notepad, guys, and you tell me what command I will run on router number 1 first. What
Configure
should be the
terminal.
first? I will enter in
Config
configure terminal.
Hmm.
So let's say config
Config T.
T, then interface fast ethernet 0/0, then no
Yes.
shut, and then
IP
IP address.
address.
What IP address here I will configure? Let's say 12.1.1.1. Any IP address you can configure. As I told you, I am using this scheme to configure IP between routers, and most of the time, and most of the people are using this method, like 10.1.2.0 means 1 on router number 1. You can use any method. You can configure any IP addresses between routers. I am using 12.1.1.1, and then subnet mask 255.255.255.0. Right, this command will assign IP address on fast ethernet 0/0, then exit and interface fast ethernet 1/0. On this interface also I need to assign IP, say so no set and IP address. What will be the IP here? 13.1.1.1, let's say 255.255.255.0. Exit. Then as I told you, I need to create one loopback here. I will create one loopback, and on that loopback interface I will configure IP from this subnet 10.1.1.0/24. So say interface loopback 1, and then on loopback interface, as I told you, loopback is a virtual interface. So here you don't need to run no set command. By default, virtual interfaces are up on routers and switches. Okay, so here we don't need to run no set command. Directly we can say IP address. What will be IP? 10.1.1.1 subnet mask 255.255.255.0. This is IP configuration on router number 1, right? This is configuration of R1. Correct, guys? Then IP configuration on the R2. So let me copy this part of configuration, and here we need to change something. This is configuration of R2. On R2 again we have fast Ethernet link, and on fast Ethernet 0/0 we will configure IP 12.1.1.2. On fast Ethernet 1/0 between router 2 and router 4 I will use 24 subnet. So here I am going to configure IP 24.1.1.2. Subnet mask is same, and here we don't need loopback. So let me remove this configuration. Done. This is IP configuration on router number 2. Then IP configuration on router number 3. Let me copy this part of configuration, and here let's say this is R3 configuration. On fast Ethernet 0/0 IP address will be 13.1.1.3, and on fast Ethernet 1/0 means between router 3 and router 4, let's say I am using 34 network. 34.1.1.3 is the IP address. Done. And let me copy it, and let me configure IP on R4. This is, let's say, R4 configuration. On R4 fast Ethernet 0/0 IP address will be 24.1.1.4, and on fast Ethernet 1/0 here IP address will be 34.1.1.4. correct? And we have one loopback interface, loopback 1, and then we are going to say here IP interface loopback 1 and IP address 20.1.1.1 255.255.255.0. okay, so hope this is clear. This is only IP configuration. On all routers we are going to configure these IP addresses. Fine. After that we need to configure a static routing configuration. Static routing, again R1. On R1, how we will configure a static routing, guys? IP route. This is the syntax. IP route, and then which network? R1 is connected with 10.1.1.0 network, right? R1 don't know about 20 network, right? 20.1.1.0/24 network. So you have to make one entry for 20 network here. Should I configure a static routing for 24 network, like the network which is running between router 2 and router 4? Tell me. Should I configure routing on router number 1 for 24 network?
Not required, sir.
Not
Only
required.
the next hop we can point out.
Right, 24 network is not required on router number 1, because router 1 is not going to ping 24 network, any IP address from 24 network. So here network on router number 1 only 20.1.1.0/24 network is required. So IP root and then network ID 20.1.1.0, then subnet mask 255.255.255.0, and then next hop IP address or exit interface. First you will define what? First we will define exit interface or next hop?
Exit interface.
Exit interface, fast Ethernet 0/0, and next hop IP address is 12.1.1.2. 12.1.1.2. Right now, see, whenever router 1 need to forward traffic in this network 20.1.1.0, router 1 will forward traffic from fast Ethernet 0/0. Next hop is router number 2. Definitely router 1 will forward traffic to router number 2. This is the only configuration on router number 1, right? But what will happen if, let's say, link between router 1 and router 2 will goes down? We have two paths between source and destination. we have two paths between source and destination. But if let's say link between router 1 and router 2 will goes down, we cannot, then we don't have reachability between source and destination. So it is better to configure one more path for this network on router number 1 with higher AD value. We will talk about that later, just leave it for now. On router number 1 we will run only this command. After that on router number 2, what command I will run? IP route and which network? On router number 2 we should configure both 10 network and 20
Same
network.
20.1.1.0.
Okay, 20.1.1.0. Mask is 255.255.255.0 and exit interface is fast Ethernet 1/0 and next hop IP address is 24.1.1.4, right? And in the same way you can configure a route for 10 network also, like 10 network is also not connected with router number 2, so we can define this network also. But it will, router 2 will not use 10 network because router 2 is not going to receive any traffic from router number 4 for 10 network, because router 4 is going to forward all traffic for 10 net. Whenever router 4 need to forward traffic in 10 network, it is going to forward traffic to router number 3. We will configure a static routing so that router 4 will forward all traffic to router number 3 for this network, for 10 network, right? Okay, but here also I am configuring one route for 10 network. For 10 network, exit interface will be fast Ethernet 0/0. 10 network is reachable from 0/0 and 20 network is reachable from 1/0. Okay, and then next hop IP address 12.1.1.1. Okay, then R3. On R3 IP route 10.1.1.0 255.255.255.0 fast Ethernet 0/0 and 13.1.1.1. correct? Clear? And IP route 20.1.1.0 255.255.255.0 and fast Ethernet 1/0 and next hop IP address is 34.1.1.4. correct? Then router number 4. Hope it is clear to all. Static route configuration. R4 IP route 10 network 10.1.1.0 255.255.255.0 exit interface. What will be the exit interface?
1/0.
1/0 and next of 34.1.1.3. This is the configuration only. Let me now paste these command on routers. Before that, let me access these all routers here. R1, R2, R3, R4. Okay. First, I am going to copy the configuration of router 1 IP configuration. So this is the configuration. Let me copy it and let me paste here. Okay, I have assigned the IP address. How to verify the IP configuration? Sorry, I have put this IP configuration on router number 4. So what we can do? Simply I can say interface range F0/0 to F0/0 and let's say F1/0 and I can say no IP address. Then we have one loopback also, interface loopback 1. I can say no interface loopback 1. That's it. Now you can see on router number 4 I don't have any IP address. So IP interface brief. Don't have any IP addresses. Okay, done. We don't have loopback interface also. I'm going to paste this command on router number 1. So let me paste, copy this command here again. copy and paste. Done. How to verify IP configuration? Show IP interface brief. Guys, if you will run show IP interface brief command, it will show you all interfaces, right? So to filter the output, as I told you, show IP interface brief, and then we can say pipes exclude unassigned. It will show me only assigned interface. It will filter the unassigned interface. Done. So now you can see on fast Ethernet 0/0 IP address is 12.1, on fast Ethernet 1/0 IP address is 13.1, on loopback 1 interface IP address is 10.1. Now I am going to copy the configuration of IP configuration of router 2 and let me paste here in the console of R2. Done. On router number 2 also we can verify, so IP interface brief exclude unassigned. On fast Ethernet 0/0 IP address is 12.2, on fast Ethernet 1/0 IP address is 24.2. Then let me copy the IP configuration of router 3 and let me paste it in the console of R3. Copy, paste. Done. Here also we can run same command, so IP interface brief exclude unassigned. So on fast Ethernet 0/0 IP address is 13.3, on fast Ethernet 1/0 IP address is 34.3. Then router number 4 IP configuration. Let me copy this part of configuration and let me paste here. Done. IP configuration is done on all routers. So IP interface brief, and we can say exclude unassigned to filter the output. Fine. Now 10.1.1 cannot ping to 20.1.1.1 because router 1 don't have root, so IP root. Here you can see the routing table of router 1, only directly connected networks are there. So we need to configure one static route here for 20 network. So I am going to run this command, IP route 20.1.1.0, subnet mask 255.255.255.0, exit interface fast Ethernet 0/0, and next hop IP address 12.1.1.2. Done. Now if you will check routing table, do so IP route. You can see in the routing table there is one static route available now, right? And again, if you are running this command, show IP route, it's showing you entire routing table. Like if you want to see only a static route in the routing table, so you can say show IP route static, right? So it is showing you only static route. Done. Now on router number 2, as I told you, we will configure both IP route 10.1.1.0, 255.255.255.0, and the exit interface is fast Ethernet 0/0 for 10 network, and next hop IP address is 12.1.1.1, and then IP route 20.1.1.0, 255.255.255.0, fast Ethernet 1/0, and 24.1.1.4. Done. Do show IP route static. You can see we have two static route in the routing table of R2. Then R3 IP route 10.1.1.0, 255.255.255.0, and fast Ethernet 0/0 is the exit interface, and next hop IP address is 13.1.1.1. Then IP route 20.1.1.0, 255.255.255.0, fast Ethernet 1/0, and next hop is 34.1.1.4. Done. Do show IP route static. Done. We have two static route in the routing table of router 3, and finally I am going to configure router 4. IP route here in directly connected network is 10, so 10.1.1.0, 255.255.255.0, and exit interface. See, what I want, that router 4 should forward traffic in this network via router number 3. So exit interface will be fast Ethernet 1/0, and next hop will be 34.1.1.3. Done. And now I am going to first check the connectivity between these two LANs. So from router number 1, if I will ping 20.1.1.1, will ping work, guys? If I will ping 20.1.1.1 directly here without defining source, will this ping work?
Hopefully, it should work.
No,
No,
it
it
will
will
not
not.
work. Why?
Because the return it will be sending from this F0 address only, right?
Yeah, if I will ping like 20.1.1.1 from here, what router 1 will do? Router 1 will check their routing table, so IP route. In their routing table, one route is available for 20 network, right? And exit interface is fast Ethernet 0/0. Next hop is 12.1.1.1. What router 1 will do? Router 1 will encapsulate one ICMP packet. ICMP packet. In ICMP packet, source IP will be the IP address of exit interface. Source IP will be 12.1.1.1 and destination will be 20.1.1.1. Router 1 will forward this traffic to router number 2. Router 2 will check their routing table. For 20 network, there is one route available. Router 2 will check this routing table. Let me show you that also. So IP route. This routing table, in their routing table also there is one route available for 20 network. Where it is? Here it is. 20 network reachable via 24.1.1.4 exit interface is fast Ethernet 1/0. Router 2 will forward it to router number 4. Now router 4 will generate reply for which IP address? Where?
12.1.1.1.
Yes, it will generate reply for 12.1.1.1 because traffic is coming, source is 12.1.1.1. 12.1.1.1 is sending this ICMP request message, so it will again generate one ICMP reply message. In ICMP reply message, source will be 20.1.1.1 and destination will be 12.1.1.1. And router 4 will check again their routing table to forward traffic to 12.1.1.1. But so IP route, in the routing table of router 4 there is no any route available for 12.1.1.1. Yes or no?
Yeah, that's correct.
Correct. Now from router number 1, if I will ping again 20.1.1.1, see first of all ping 20.1.1.1, ping is not working, right? You can see here ping is not working. हाँ क्या हुआ? Okay. Okay.
Sir, before you proceed, can you please write the IP for R2?
Here we are running this network 12.1.1.0/24. Here we are running 24.1.1.0/24. Here we are running 13.1.1.0/24. And here we are running 34 network 34.1.1.0/24. Okay, Somnath.
Yeah, in F10, right?
Between router 1 and router 2.
Okay.
On F1 we are on router number 1 F0/0 I am running 12.1. On router number 2 I am running 12.2. On router number 2 fast Ethernet 1/0 I am running 24.2. And on router 4 fast Ethernet 0/0 I am running 24.4.
Okay.
Let me write that also. Here we are running .1. Here .1. Here .2. Here again .2. Here we are running .4. Here also we are running .4. Here we are running .3. Here also we are running 3. And here we are running .1. Okay?
Okay, sir.
Fine. Now from router number 1 you can see if I am pinging 20.1.1.1, ping is not working because route is not available on router number 4. So if you want to directly ping 20.1.1.1 from router number 1, what you have to do on router number 4, you have to configure one more static route. Let me do that. On router number 4, I am going to configure one IP route, let's say 12.1.1.0, 255.255.255.0, or exit interface is fast ethernet 0/0. That's it, let's say. Right now, can I ping? Now will ping work? Now why ping is not working? Yeah, ping is working now. Ping should work now, yes or no? Because now router 4 have root for 12 network for the source, right? But if I will remove this entry, let me say no here, you can note ping 20.1.1.1 with source 12.1.1.1, but you can ping 20.1.1.1 with source 10.1.1.1. Now my LAN user is going to ping other LAN user, right? This ping will work, right? And now guys, I'm going to trace route 20.1.1.1, or how to find which path router 1 is using. Trace route 20.1.1.1 and source 10.1.1.1, say numeric, see my path. Router 1 is forwarding traffic to 12.1.1.2, means router 2, and router 2 is forwarding traffic to 24.1.1.4, means to router number 4, correct? And from router number 4, I am going to trace route 10.1.1.1, trace route 10.1.1.1, and source is 20.1.1.1. See, traffic is going to router number 3, 34.1.1.3, IP address of router 3, and then router 3 is forwarding traffic to router number 1, 13.1.1.1, right? Correct? So path from 10 network to 20 network is via router number 2, and path from 20 network to 10 network is via router number 3. Is it clear to all? So sometime interviewer can ask you this question also, that can we achieve load balancing in case of static routing? So yes, it is possible. But what is problem here? Problem is, if this link between router 1 and router 2, or link between router 3 and router 4, or let's say link between router 2 and router 4, or link between router 3 and router 4 will goes down, LAN users cannot communicate, correct?
Sir, same like ring topology, right?
Ring topology means?
Ring like network should be connected like this in a ring.
Okay.
So okay.
So can you come again? That actually, what is the problem? Can you say again?
Problem is, if link between routers will goes down, let's say here on router number 2, let's say my fast ethernet 0/0 link is not working, fine, I'm going to down interface fast ethernet 0/0 shutdown. Now what will happen? Now 10.1.1.1 cannot ping to 20.1.1.1, yes or no?
Yes, exactly.
But
Yeah.
still we have path is available via router number 3, still path is there, na?
Yes.
But ping will not work. Why? Because we have configured the static routing.
Yes.
Static routing via router number 2 only. Ping 20.1.1.1, source is 10.1.1.1. See, ping is not working. Now ping will not work. What is happening here? Router 1 is forwarding traffic to router number 2. See guys, this time check routing table. So IP route. In the routing table, static route is there. Static route is there. 20 network. Router 1 will forward traffic to router number 2. Router 2 will not receive the traffic because this interface is down. So in this type of scenario, again what we need to do, we need to change the static route. Manually you have to change the exit interface and next hop IP address. This time I have to tell to router 1 that for 20 network, now next hop IP address is router 3. Correct?
Yes.
I have to tell to router that IP route 20.1.1.0, 255.255.255.0, and next hop is exit interface is fast Ethernet 1/0, and next hop is 13.1.1.3, right? And you have to remove this command also. Otherwise what router will do, router will perform load balancing, because this time router have not two path for 20 network. So router 1 will forward 50% traffic to router number 3 and 50% traffic to router number 2. Getting my point?
Okay.
So again problem is still there, right? Still if I will ping 20.1.1.1 and source is 10.1.1.1, see ping is not working. Got it? So here I have to remove one static route entry, config T. We can check do so run. In the running configuration I am going to check section IP route command. So I am going to say no to this. I'm going to remove this one, say no and hit enter. Correct? Now see ping is working. Ping is working. Ping is working, guys, right? Via router number 3. If you will trace route now 20.1.1.1 and source is 10.1.1.1, you can see traffic is going via router number 3. Let's say on router number 2 again this interface will come up. Interface fast Ethernet 0/0, say no shut. Now your primary path is up. Again you have to change the static route configuration on router number 1. Correct? Again you will remove one entry, this entry, previous entry, and you will configure again static route via router number 2. Am I right? So that's why we have one option, that is floating routing. In a static routing, guys, there are two types of static routing, right? Floating routing and normal static routing. In floating routing, as I told you, that AD value is something. Let me talk about administrative distance value first. Administrative distance. What is administrative distance? Administrative distance is nothing but it defines reliability of route, that which route is how much reliable. It is reliability of routes, right? By default here on router number 1 you can see I don't have any entry. Let me configure a static route, IP route, and 20.1.1.0 mask is 255.255.255.0, and next hop exit interface is fast Ethernet 0/0, next hop is 12.1.1.2. Done. Now so IP route, in the routing table you are able to see these two values.
Yes.
Right? And here again I am going to configure this static route and put question mark. Here you are able to see the distance. This is nothing but AD value. Let's say here if I will configure AD value 10, and now if you will check routing table, so IP route, this time you can see AD value is 10. Less number is more reliable. By default AD value for a static route is 1, and whatever dynamic routing protocol we are going to learn in upcoming day, each routing protocols have their own AD value. Like there are, let me compare two routing protocol like RIP and EIGRP. So both will have one AD value. And the protocol which will have lowest AD value will be more reliable. Their route will be more reliable, right? So by default AD value for a static route is by default 1.
Yeah.
Right? So let's say I have configured on router number 1. First of all, let me remove this command from router 1. Say no to this. no to this, and I am going to configure IP route 20.1.1.0 255.255.255.0, and next hop exit interface is fast ethernet 0/0, and next hop is 12.1.1.2. Done, one entry. And I am going to create one more entry via router number 3, 20.1.1.0 255.255.255.0 fast ethernet 1/0 and 13.1.1.3. right now, do so IP route static. Done. How many paths we have for 20 network? 2 paths. And for each path, what is AD value? 1. So router is going to give equal reliability to both paths. So router is going to perform what? Load balancing. But I want to tell to router 1 that until and unless this path is available, means via router number 2, if path via router number 2 is available, you should use this path only. And if this path is not available, in that scenario you should use this path. So what here we can do? We can increase the AD value of this path. Yes or no? We can increase the AD value of this route. By default, both are static route. By default, AD value for both is 1. Getting my point? So router is performing load balancing this time. It is forwarding equal traffic from both paths. But if I will configure higher AD value over here, right, router will stop using that path, because now router will compare which path is more reliable. If this path is more reliable, router will forward all traffic via this path only. If this path is more reliable, router will forward all traffic via this path only. So I am going to remove one entry here. Do so IP. So do so run section IP route. I am going to remove this configuration via router number 3. Say no to this command, and then IP route 20.1.1.0 255.255.255.0 exit interface is fast ethernet 1/0 via router number 3. 13.1.1.3 is the next hop IP address, and here I am going to define AD value 10. Right now, if you will check routing table, so IP route static, let's say, how many paths is there? Only 1. But if you will check the running configuration, so run and section IP route, how many paths is available in running configuration? 2. Right, 2 entry is there for same destination for 20.1.1.0 network. But this path is more reliable, because of that router have installed this one in their routing table. Router have not installed this path in their routing table. But if fast ethernet 0/0 will goes down, router will automatically install this path in their routing table. See, fast ethernet 0/0 says shut down, and now if you will check routing table, you can see, so IP route static. Router have installed which path? Via router number 3 automatically. And again, when fast ethernet 0/0 will come up, let's say this path is, let me running no shutdown command here, automatically router will install primary path. You can see now the routing table. Getting my point? Getting my point, guys?
When it is having equal administrative distance, you said it
will perform load balancing.
Load balance. Say suppose I am sending 5 packets, so 3 packets will go on one route and 2 packets will go on the other route, or it will randomly select.
Exactly.
Okay.
Exactly. Okay. So here, have you guys understood floating routing, how to configure it and why we need to configure it? If fast ethernet 0/0 is up, this interface is up, or link between router 1 and router 2 is up, router will use primary path, means this path. If link between router 1 and router 2 will goes down, router will automatically start using this path via router number 3. Got it? And after that we have some more option here like track. We will discuss about track later. Like if fast ethernet 0/0 of router 1 will goes down, router will came to know, okay, this interface is down, I should use path via router number 3. But what will happen if link between router 2 and router 4 will goes down, right? So that we can track, let's say we can track the this interface fast ethernet 1/0 of router 2 or fast ethernet 0/0 of router 4, that until and unless there is reachability between router 1 to this interface, you should use primary path. If there is no reachability between router 1 to router 4, you should use lower path. We will talk about the track later. For now, just I want to make you understand this, that what is floating routing. Done. In the same way, on router number 4 also, we should configure a static route both path by using administrative distance value. Here also primary path is lower path, so IP route and 10.1.1.0 255.255.255.0. Next hop is exit interface is fast ethernet 1/0. Next hop is 34.1.1.3, and we should configure same network with exit interface fast ethernet 0/0. Next hop is 24.1.1.2 and AD value higher value, right? You can configure 2, 3, 4, 5, 0 to 255. Done. Now here also on router 4, so IP route static, there is only one entry via fast ethernet exit interface is fast ethernet 1/0. But if fast ethernet 1/0 will goes down, interface fast ethernet 1/0 shut down, automatically router will install 10 network with exit interface 0/0. So IP route static 0/0. Now 10 network is reachable from 0/0 interface. And again, if fast ethernet 1/0 will come up, say no shutdown, it have lower AD value, so it will install lower path. So IP route static. You can see now exit interface is fast ethernet 1/0. Fine. And from router number 1, if you will trace route 20.1.1.1, source 10.1.1.1 and numeric, traffic is going via router number 2, then router number 4. If fast ethernet 0/0 will goes down, shut down, and now if you will trace route, see I am not doing anything, router is doing everything automatically, path is changed automatically, right? Again, if this link will come up, interface fast ethernet 0/0, say no shutdown. Again, if you will trace route, you can see now path is via router number 3. Router is not taking time, it is changing their routes in their routing table quickly, correct? Is it clear to all? And guys, after AD value, router will check one more thing, that is metric. We are going to understand metric in dynamic routing, right? For a static routing, metric is 0, so IP route static. The second thing is metric. This one is metric. Okay, router will check two things, AD value and metric. If both is same, then only router will perform load balancing. For a static routing, metric is always 0, and metric is concept of dynamic routing, so we will discuss it in dynamic routing only. Fine. Can I move? Can I move?
Sir, I have one elementary doubt maybe.
Okay.
Okay, see, and the first scenario when we were pinging, right? Sometimes we also do while pinging the source. Either we will set the source interface or source IP is okay. But if we don't recall the source interface, source IP and pinging from the router 1 to router 4 in the very first scenario. So when the packet goes from R1 to R2, and then the packet goes from R2 to R4, then the source IP will it not become the R2's interface? It will still remain R1's IP. Yeah?
Yeah, source IP will not change, na. Source MAC will change.
Okay. That's what small confusion actually.
Yeah, source IP and destination IP will be still same till source to destination. Doesn't matter there are how many routers are there between source and destination. Source IP and destination IP will be same. Okay.
Okay.
Now guys, let's say, okay, that is fine, that here we have reachability between these two LAN. Let's say any router, this LAN user want to access internet now. And let's say router 2 is connected with internet router. Here we have one more router, internet router. This is internet. And R2, let's say, is connected with internet. Now this LAN user want to access internet on, let's say, internet servers. On internet router we have one server. I can create one loopback on internet router also, like server. Let's say we have one loopback here, 8.8.8.8. Okay. Oh my god, 1 minute. This scenario also. On internet router, this loopback is, let's say, one server is connected with internet, and like this 8.8.8 or one single server, there are million of servers connected with internet. So is it possible to configure route on this router on R2? Is it possible to configure route for all networks available on internet? This is not possible. Yes or no? This is not possible to configure million. By the way, here this router can handle up to 1000 prefixes only in their routing table. We cannot configure million of prefixes in their routing table or lakhs of prefixes in their routing table. But from, let's say, LAN user, from router number 1, this LAN user want to ping 8.8.8.8 this time. Source is again 10.1.1.1. This LAN user want to access something on internet. What will happen? Router 1 will check what? Routing table, and in their routing table there is no any route available for 8.8.8. So here we can configure one static route for 8.8.8 IP route. We can say 8.8.8, and next hop is again exit interface is fast ethernet 0/0, and next hop IP address is 12.1.1.2. Fine. Now router 1 will forward traffic to router number 2. On router number 2 also we will configure one route for 8.8.8 towards internet. On router number 4 also we need to configure one route for 8.8.8. And like 8.8.8, as I told you, there are thousands of prefixes on internet, so it is not possible to configure each and every prefix in the routing table of these router. So what is the option now? Option is, see here, if you are running
default router.
Default route, very good. So IP route, what it's saying, gateway of last resort is not set. Means gateway of last resort is not set means this router know only these network, right? If router 1 will receive a traffic, a packet where destination node belongs to this network, then router 1 will simply drop that traffic. Router 1 will simply drop the traffic. If router 1 is receiving a traffic and destination is not matching in the routing table, in the any entry of routing table, router will drop the traffic. But if here we have gateway of last resort, let's say here I have set the gateway of last resort is router number 2. If I will tell to router 1, your gateway of last resort is router number 2, that means whenever router will not find any entry in their routing table, it's responsibility of router 1 to forward it to router number 2, because router 2 is gateway of last resort. Getting my point? So if router 1 will not find any entry in their routing table, it will forward the traffic to router number 2. In the same way, gateway of last resort is nothing but default routing. Default route means to all prefixes. Like we configure default route like this: IP route 0.0.0, 0.0.0, 0.0.0.0 means all network, any subnet mask, any network, any subnet mask, you should forward the traffic to which router? From fast Ethernet 0/0 to router number 2, 12.1.1.2. Hit enter. And now if you will check routing table, so IP route, you can see gateway of last resort is now 12.1.1.2 to network 0.0.0.0, means to all network. And there is one default route in the routing table. Now you can see 0.0.0.0/0. Again, AD value is 1 because this is one kind of a static routing, and this is reachable via 12.2, and exit interface is fast Ethernet 0/0. Getting my point? But default route will get preference when match will not found in the routing table. First router will check routing table, this entry. If, because this is last resort, if there is no entry available in the routing table, then only router is going to use default route entry. Now what router 1 will do? Router 1 will forward the traffic to router number 2. If I will ping, if I will, let's say, trace route 8.8.8.8, and source is, let's say, 10.1.1.1, right? Say numeric. See, router 1 is forwarding traffic to router number 2. Router 1 is forwarding traffic to router number 2, and from router number 2 there is no path available. Getting my point? So on router number 2 also we need to configure one default route towards ISP. On router number 2 also I am going to configure one default route towards ISP, and before that let me configure one IP address between router 2 and internet router. Let's say I am using this IP here, 1.1.1.0/30. If I don't want to waste any IP address between internet router and router 2, because this is public IP address, what slash value I should use?
30.
29 or 30.
30, na? 30,
Yeah.
because we will get only 2 IP address here. Let's say on router number 2 my IP address is .1, and on ISP end my IP address is .2. So let me configure this interface serial 2/0, say no shut, say IP address is 1.1.1 255.255.255.252, right? And then internet router, let me access internet router also. On internet router I am going to configure IP on serial 2/0, say no shut, and IP address is 1.1.1.2 255.255.255.252. Exit interface loopback 1. On loopback interface I am going to define 8.8.8.8 255.255.255.0, let's say, or 255, anything. Done. On internet router we are not going to configure anything else. I am going to close this console now. From router number 4, if I will ping 8.8.8, will ping work?
No, na. Return route from internet router also should point to.
And here gateway of last resort is also not set. So router 2 will drop the traffic, na? Because default route is not available on router, sorry, I am on router number 4. On router number 4 also default route is not available, and on router number 2 do so IP route. So default route is not available on router number 2, right? First of all, let me check the reachability between public IP address, like ping 1.1.1.2. Yeah, I am able to ping .2, and 1 is my IP address. Yes, right. Now here first I will configure one default route 0.0.0 0.0.0, and exit interface is serial 2/0, and next hop IP address is 1.1.2. Now can I ping 8.8.8 from here? Will this ping work?
No.
Why not?
From the internet router, reverse route has to point, right?
Why? Because I am pinging
Oh,
8.8.8,
okay, direct,
source will be
directly connected.
1.1.1.
Okay, okay. But in that case, you have to include the
Configure
source
default
interface or the source IP.
Yeah, I am not defining source anything. then it should work na, ping should work, because default route is available. When I will ping 8.8.8, what router 2 will do? Router 2 will check their routing table. In their routing table there is no any route available for 8.8.8, but there is one default route towards serial 2/0. So it will forward the traffic from serial 2/0, ping 8.8.8.8. See, ping is working. It will forward the traffic to router, internet router, and internet router will receive the ICMP packet with source 1.1.1, destination 8.8.8, and 1.1.1 is reachable na, from internet router. So that's why ping is working. But this LAN user cannot ping. Definitely LAN user cannot not ping, or router 2 cannot ping from their LAN interface, like from fast Ethernet 0/0. For that, here you have to configure NAT. For that you have to configure NAT here, network address translation. Guys, we will understand the network address translation. For now, let me configure the NAT only. Say access list and permit 0.0.0.0 and interface serial 2/0, IP NAT outside, exit interface fast Ethernet 0/0, IP NAT inside, exit interface fast Ethernet 1/0, IP NAT inside, and IP NAT inside source list 10 interface serial 2/0 overload, and ping 8.8.8.8, source is fast Ethernet 0/0. Why ping is not working? Anyone know natting? So access list, no access list 10, access list 10 permit. We can configure access list like this 10 permit. Let me permit this IP address to 12.1.1.2 0.0.0 and ping 8.8.8. Source is fast Ethernet 0/0. Yeah, ping is working, right? And let me correct the access list. No access list 10, IP access list 10, standard 10 permit which network? 12.1.1.0 0.0.255 permit 10.1.1.0 0.0.255. Okay, leave. This is the NAT concept. We will discuss NATing later. For now, you can see I'm able to ping 8.8.8 from source interface fast Ethernet 0/0, means from the LAN interface. In the same way, all routers will have one default route towards the edge router. Router 1 will have one default route towards router number 1, router 1 will have one default route towards router number 2, and router 3 will also have one default route towards router number 2. So this is all about a static routing. In a static routing, we understand default route configuration also, right? We can configure one route for any prefix, you can say, for any network, you can say. We understand the floating routing as well, like if we have multiple path and I want to use path like primary and secondary, or it can be used, in this scenario, like, let's say this is my router, edge router, and this edge router is connected with two different ISP1, and this is ISP2. Let's say this is my primary ISP and this is my secondary ISP. Here we have, let's say, 1 Gbps link, and here we have, let's say, what we can say, 512 kbps link. Okay, kbps link. So this is my primary ISP and this is my secondary ISP. So on this router you will configure two default route, one towards ISP1 and one towards ISP2. So how you will configure default route? 0.0.0/0, 0.0.0/0, and here exit interface is, let's say, ISP1, and here exit interface is ISP2. Here we can define, we can configure AD value default, and here we can set higher AD value, let's say 2. So until and unless ISP1 is up, router 1 will forward all traffic towards ISP1. If ISP1 is down, then router 1 will start using this default route, because here we have what AD value 2. Getting my point? So actual implementation of these things like static routing configuration or default routing configuration, you will understood the actual implementation, but not now. First understand the small configuration or small concepts, then at the end you will understand the actual implementation. Okay guys?
Sir,
Hmm.
can we do path manipulation using longest mask bit and short mask bit mask
Shortest?
subnet mask?
Yeah, we can. We will understand it in dynamic routing.
Not in the static routing. Can we do it
In static routing also, let's say on router number 4, guys, on router number 1, let's say we have some more network 10.1.1.0/24, 10.1.2.0/24, 10.1.3.0/24, 10.1.4.0/24, and 10.1.5.0/24 are there. These loopbacks are there on router number 1. Now what I want, that for upper 3 network, we should use path via router number 2, or and for lower 3 network we should use path via router number 3. This is your question. Am I correct? Is it your question that how to perform load balancing like this?
No, I'm asking if the mask bit is 16 with /24/16, the highest mask bit is preferred like that. Can we do the path manipulation?
Let's say here we have 16, here we have 17, like this. Like this.
For configuring IP route.
Yeah, by configuring IP route also we can here we have option to define subnet mask, like on router number 1 IP route. And wait, first let me explain this also. See guys, here like we have now 5 loopbacks, and I want that for upper 3 prefixes, means for these 3 prefix we should use this path via router number 2, and for lower 2 prefix I should use these 2 paths. How I can achieve this task?
PBR, sir, policy based routing.
No, static routing.
Oh, in static routing.
And this only I asked.
This
Means
only you ask.
actually we have to define it manually, here.
What manually? Okay, can anyone tell me what will be the summary address of upper 3 network?
Sir, AW is 0 upper 3 networks.
Summary address of upper 3 network 10 dot.
10
How
dot
to find summary address?
10.1.
You mean
10
super
dot?
netting, huh?
/22.
Yeah. 10.1.0.0/22.
Yes.
And this one, these two summary addresses 10.1.4.0/22. So now you will configure 2 static route here. One is this one, and
Sir,
one is this
second one will be
for
/23, right?
/22 na?
No, only two.
/22.
4.0 and 5.0 means /23 only, right? Only 2/24.
Here this one, I think it should be 22 na?
I guess
If
it's
you will
22.
summarize these two networks.
You mean super netting, right? It should be 20. 0, 1, 2, 3. 4,
What
5
is the
means
binary of
23 only,
4?
sir. Because if
Here
you say
23.
22 means actually 22 means 4 into /24. Right, so if you put 10.1.4.0/22 means from 4.0 to 456 7.0.
Okay. 252. Binary of 4. Binary of 4 is this one,
100.
Yes.
right?
Yes.
And binary of 5 is,
101.
Hmm.
how many bits are common here?
7 bits.
So 7 bits are common, na? 2, 4, 6. 6 bits are common. 7 bits are common.
7 bits are common.
7 bits are common. So what should be the slash value here? Slash value should be what? 16 plus
22.
7. So it should be 23.
23. 23.
Yeah, that's what I told.
Yeah. No problem. I can also do mistake, brother. Yes or no?
Yeah, no,
Yeah.
because I know that I told sir nothing like pointing out.
Yeah. Okay, so now we can configure a static routing. Like for this network, we will define this as a exit interface. For this network, we will configure this as a exit interface. Configuration is same. Like, getting my point? Yes or no? Configuration is same. Static route configuration is same. Should I configure it, or you guys can configure it by yourself? Tell me.
You can demonstrate, sir, please. We'll replicate.
Let me configure it. On router number 1, I am going to first create this loopback interface. Here I am going to write down the command in Notepad. Interface loopback 1 IP address 10.1.1.1 255.255.255.0. Let me copy this. Loopback 2, loopback 3, loopback 4, loopback 5. This is 2. Here IP address is 10.1.2.1. Here IP address is 3.1. This is loopback 3. This is loopback 4. Here IP address is 4.1. Here loopback 5. This is 5.1. Okay. Exit. Copy. Let me paste it on R1. Done. Do so run section IP route. I'm going to remove these all entry. Say no to this, no to this, and no to this default route also. Let's say, let me remove this default route. Right now, for this network, on which router I need to configure routing? On router number 4. Am I right? So on router number 4, I'm going to configure. Sorry, on router number 1, I have removed the static route configuration, but I should remove it from router number 4. Do so run section IP route. Say no, this, no to this, and then IP route summary address of upper 3 network 10.1.0.0 subnet mask 255.255.248. 248. Is it correct? 252 na? 252.0. Right? Right, guys? Exit interface should be what? Fast Ethernet 0/0. and next hop IP address is 24.1.1.24.1.1.2. Fine. Then IP route 10.1.4.0 255.255. What will be the subnet mask here?
254.
254.0. Exit interface is fast Ethernet 1/0 and next hop IP address is 34.1.1.3. Now if you will check routing table, so IP route, if so IP route static if router 1 router 4 will receive any traffic for this network, it will forward traffic to router number 2. If router 4 will receive any traffic for this network, it will forward traffic to router number 3. On router number 1, again I am going to configure the static route, which I have removed. Route 20.1.1.1 and 255.255.255.0 20.1.1.0 and next hop IP address is 12.1.1.2. Exit interface first is fast Ethernet 0/0. Next hop is 12.1.1.2. Now from router number 4 I am going to trace route. Trace route 10.1.1.1. Source is 20.1.1.1, say numeric. Path is via router number 2 or via router number 3.
Router 2.
Via router number 2 for 10.1.2.1. For 10.1.2.1 also. What happened? 10.1.2.1 is not configured here.
No, the other route you have to reverse route. You have to configure.
For 20 network 20.1.1.0, for 20 network we have path na on router number 1.
Okay.
On router number 1, so IP interface brief 10.1.2.1 is the IP, that is correct. Let me ping 10.1.2.1. Source is
There are two P's.
20.1.1.1. Why ping is not working? Because we don't have routes on router number 2 and router number 3. So what I am going to do, on router number 2 I am going to configure one default route towards router number 1. No IP route. First of all, let me remove the default route because we have one default route here. And then I am going to configure one default route towards router number 1, let's say. Otherwise you can configure the routes for for these networks on router number 2 and router number 3, 0.0.0 and fast Ethernet 0/0, and on router number 3 also IP route 0.0.0 0.0.0 fast Ethernet 0/0. Done. Now I think it should work. Ping should work. Yeah, ping is working. And now again I am going to trace route 10.1.2.1. Source is 20.1.1.1. Say numeric. Right. Traffic is going via router number 2. Let me ping trace route 10.1.3.1. Traffic is going via router number 2. But when I will trace route 10.1.4.1. 4.1, traffic is going via router number 3. And for the last network for 10.1.5.1, traffic is going via router number 3. So you can configure these things by yourself, right? Concept is same, right? This is concept of summarization or subnetting. We can perform load balancing like for some prefixes, for upper 3 prefixes via router number 2, for lower 2 prefixes it should use via router number 3. Correct? Any doubt?
But
Tell me, yeah. But what, brother?
No, I was thinking like no, on the router 2 and router 3, if you are pointing the default routes towards R1, if you are pinging from R1 with a different source IP that is
No,
available.
on router number, I have tell to
Okay,
router
okay.
2 na, that if you will receive any traffic and you will not found any entry in the routing table, you should forward that traffic to router number 1. And same thing on router number 3 also. I have configured one default route to save the time. Otherwise, on router number 2 and router number 3 also, we need to configure routes for this network na.
Yeah, okay, sir. So yeah, provided it will work only if from the router 2 and router 3 we have pointed towards router 4 thing. Okay.
Towards router 1. Because router 2 don't know about these three network, right? Router know only upper this network. Router 3 also know only upper this network, because we have configured routing for only this network na. So that's why I have configured, I have point out
No, no,
towards
no,
router
no.
number
My
1.
question was like from R2 and R3, if let's say we are pinging from R1, we are pinging 20 dot network, right? So from R2 and R3, that this 20 should have some static route. That one we have not
Yeah,
included, right? Yeah,
for
okay.
20
Then
these
it will
router
work.
have na routes. For 20 we have already configured routes now on router number 2 and router 3.
Yeah, okay.
Here only I have added these network na, brother. Yes or no?
Yeah, okay, sir.
So now hope static routing is clear. You guys can configure it, and you should configure it by yourself. You know, different topologies are there. If you will check your books, there are also multiple topology, multiple tasks are there, right? So you can practice it. And now we should start dynamic routing from the next class. And dynamic routing is very important, right? And it is, you know, very interesting also, because a static problem with a static routing is, static routing is good for a small network. Benefit of, first of all, if I will talk about the benefit of a static routing, so benefit is CPU. In a static routing, CPU utilization is very less, because we are not running any process, any protocol on routers. So if you want to save the CPU utilization, or let's say your router don't have a high or CPU or RAM or memory, your router don't have CPU, then you can configure a static routing. If you want to run protocol, dynamic routing protocol, definitely CPU is required, RAM is required, memory is required, right? Because there we are going to run protocols, process. According to that process, router itself going to learn the network from their neighbor router. Router 1 itself going to tell about these all network to their neighbor, to router 2 and to router number 3. So if you are running a static routing, you don't need to invest lots of money to purchase router. You can purchase normal routers with less memory, less CPU. But if you are planning to run dynamic routing, like in last class someone said that BGP is an recursive protocol. Means in BGP you will see by default BGP will perform recursive lookup every time, right? So to run BGP routing protocol, again you need good routers, you need more CPU, more memory, more RAM than running OSPF or EIGRP or other routing protocol. In the same way, if you want to run protocol on router, you need good memory, good more RAM, more CPU. So if you have less memory, less CPU, you can run a static routing. Problem with a static routing is, when my network is large, in large network it is very complicated to configure static routing. And second is, let's say here we have, like as I told you, that here on router number 1 we have two paths, right? Via router number 2 also, via router number 3 also we can configure the floating routing. But if we have not configured the floating routing, then manually we have to change the path. Manually we have changed the path. Means let's say here bandwidth is more, here bandwidth is less. What I want, that router should negotiate the bandwidth of link. According to bandwidth, router should decide that which path is best for forwarding traffic in 20 network for router 1. Automatically router should decide it that which path is best for me according to bandwidth, according to the link properties, according to the maybe hop count, right? So these things is not possible in case of a static routing. In a static routing, router know only what you have defined, what you have configured. Getting my point? So this is again disadvantage also of a static routing. And whenever you will learn dynamic routing protocol, there are multiple dynamic routing protocol, like we have RIP, we have EIGRP, we have OSPF, we have BGP. So you have to understand advantage and disadvantage of each protocol, that what is the disadvantage of RIP, why we come up with EIGRP, what is the disadvantage of EIGRP, why we come up with OSPF, and what is the disadvantage of OSPF, why we come up with BGP, and if BGP is good, then why we are still using OSPF. So what is the benefit of OSPF over BGP, everything. Getting my point? So a static routing is important and still we are using it. If someone is thinking that we are not using a static routing nowadays, so no guys, we are still using a static routing if we have a small network, and all routing protocols also still we are using RIP routing protocol. It's totally depends on our requirement. Let's say you have less number of router and you don't have on your router, memory is less, CPU is less, RAM is less, then you should use dynamic routing protocol like RIP, not OSPF or BGP. So where we will use BGP, where we will use static routing, where we will use OSPF or RIP or EIGRP. You have to understand all routing protocols first. Then according to requirement, we can use any routing protocol or any method to configure routing. We are using everything. Okay. So yes, now if anyone have question from the static routing, please.